Welcome to our factory automation debate. There has been much written about Industry 4.0 or Smart Factory 1.0. We want to look today at some of the practical steps that companies should take to start the automation journey. So today we've brought together a distinguished panel of, I hesitate to call them experts, but people who are very well known in the industry, to basically talk about it and debate about this, how the factory automation business is developing. Going from left to right, we have Michael Ford from Mentor Graphics, Valor Division, Jason Spira, President of the Aegis Corporation. Bjorn to my right, extreme, we have Bjorn Dahl from Kick, and to my extreme right, Bob Black from Juki Corporation. Okay, welcome, gentlemen. So I wanted to start out with a round of individual questions to open the debate, and then we'll open the debate to a wider discussion. So I'll start with you, Michael. You recently introduced an open source software platform called OML. How does it work and how secure is it?
Yeah, the OML language is about a month ago we released the specification for anybody to download and use. It's completely free, and so what we wanted to do by doing that is to really bring back the advantage of electronics with the Internet of Things. Mm-hmm. We see other industries already embracing new technologies, but due to the myriad of different formats from all of the different machine vendors, the information is coming. It's a huge amount of work for anybody, any customer or any software provider like ourselves, to actually keep up with that level of change in the industry. Right. So what we wanted to do was to say, okay, here is a specification that everybody can use. This is something that is powerful enough to represent any event or process on the shop floor. It links not only to machines, but also all the way down to even the simplest manual operations. Right. And we want people to go ahead and take that specification, develop things for themselves.
Okay. Now, but with open source, always there is an element of security. How secure is it?
We have security built into that. I mean, the security of data, of course, between different customers, if that's being used in a contract manufacturing environment. Mm. So we have the levels of security built in. Mm-hmm. Okay. So it's all part of the base core code itself.
Okay. So thanks for that. We'll maybe open up on that later in the discussion. But in the meantime, Jason, Dr. Nolting, who's your representative in Europe, told us at the Productronica debate that Aegis has many agreements with machine vendors to access data using the CAMEX interface that was developed by IPC a number of years ago. But IPC, the CAMEX is not really kept pace with developments. And being driven by trade association, it's not quick to change or quick to adapt. What are you doing, and how are you going to handle this going forward, for the future automation?
Yes, actually our view isn't too dissimilar to Michael's. Mm-hmm. We had a library of hundreds of CAMEX adapters to actually our friends here and virtually most of the machines in this mm-hmm. hall. However, you're right, CAMEX has not evolved over the years for myriad reasons. It's been basically stagnant, and we had to extend it ourselves in order to, but we wanted to build upon something that was standards-based through mm-hmm. an organization such as the IPC. But the goal of what Michael was discussing is something we actually agree with, is there should be an open standard that is agreed at the industry level, so this mm-hmm. is not necessary any longer. It is a very complicated affair for both our companies to maintain right. what are effectively custom adapters to the machines. It is a much better approach to go with something that is agreed upon and mm-hmm. standardized. Okay,
that's interesting to know. Now, turning attention to the equipment side here, Bob, ASM celebrated an industry first at Productronica with the introduction of a solder-paste inspection system that automatically corrects the offsets and other parameters on the printer. How close is Juki to achieving this level of automation?
After we're done, Trevor, you can walk up and see it in the booth. We chose a little different path than our friends at ASM. We're working with Cyber Optics, which we've worked with a long time on sensors for our placement machines. And we have now integrated the cyber optics, both their 500 series and 600 series SPI machines, with a full integrated feedback to our GKG printers.
Okay.
And we can correct quite a few parameters automatically. We're finding now when you run a new board, it takes about 3 boards to get it optimum, and then you're ready to go. And we're currently having a project to feed forward to the placement machine from the cyber optics for any solder offsets that are measured, so that for small component placement, we can offset the placement to match the solder position and avoid things like tombstones and billboards. So well underway. Welcome you to come and see it.
Ideal. It sounds interesting. I definitely will, for sure. Bjorn, most people involved in Industry 4.0 would agree that it's a journey, it's not a destination at the moment. KIC produces a huge amount of process data related to oven recipes and that sort of thing. How do you see this data being utilized further up the line on other machines, and if so, how?
So the first thing to look at is why the data is collected and why people would want to access that. And historically, that's been process traceability. It's been to avoid that human mistakes happen by taking data directly from the sensors and controlling ovens. In the future, I think we see more and more of a need for equipment utilization to increase uptime and so forth. So some of these data can be used locally. If you want to read a barcode of an incoming board to make sure that you can load the right recipe. But I think more and more as we move forward, you want this data available throughout the whole factory, not just up and down the line, upstream, backstream machines, but also other lines. And I think that the MES companies will play a very central role. So I think the vast majority of the data that we acquire and analyze and distribute will end up with the MES system as a integral part of everything else we're doing for the factory.
Yeah. When you start talking about process data and there's so many different parameters, the types of paste you use, the types of flux you use, etc., and they all reflow in different ways. It's going to be a huge job on the process side.
Yeah, essentially what a reflow oven is, to take that example, it's what is the purpose of a reflow oven? It really is to create a profile on the assembly that is within specifications. So you need the process window information. You need a means to measure the time versus temperature profile of that PCB as it goes through the process. And then what you do with that data can either be sent off to the MES for traceability purposes or for further machine control, or, as I said before, it can be used locally.
Okay, good. So, thank you for these initial questions, gentlemen. Now we're going to widen it a little bit to general questions, so you're all welcome to chip in as we go through it. My first one is for an EMS manufacturer looking to develop a plan to implement greater factory automation in his facility. Where should he start? Who wants to go first on that?
I think the starting point is to choose the best machines for the job, to look around for machines which will fulfill the need in terms of the business need. The question then becomes how to connect those things together so that they can be managed. If you look at Industry 4.0, automation is actually Industry 3.0. It started in the 60s.
Right.
That's where automated machines came in. What we're talking about today isn't that. It's about how to make the best use of those automated machines.
Right.
And that's what we see as being a function of gathering the data from those machines and feeding them up into these computerized processes. By doing that, then we increase the effective productivity and the flexibility to respond to short-term customer needs.
Right.
So what I see as being the key thing for the future, and actually, if you bear with me, I actually have it.
We're going to get a product here.
I have it in the box. So, here, you saw it here first. This is a box that I can take from here. I can put it next to any machine in this building. I plug in the power, I plug in the connector, and I can get the open manufacturing language data straight out of that machine and straight into any existing MES or ERP system.
Okay.
So not just the software for Mentor Graphics. I mean, this is to promote data to anybody's software, your software. You could take this, you could exchange information through this box. So this has inside it the interfaces to every machine on this shop floor. You just put the box there, wire it up, and off it goes. This is the future because it enables the communication between all of the machines on the shop floor and the existing kind of software upstairs. So nobody needs to buy new machines. Nobody needs to buy new software in terms of MES ERP. It's all ready to go. Internet 4.0, Industry 4.0, Internet of Things. It's right here, right now.
So
That sounds incredibly simple, that I could just buy a box and solve all my issues. Are you sure? How have you tested the fact that it links up and runs with every machine? Because if it does, it just made my life a whole lot simpler.
Well, the thing is that we, and I'm sure our friends here, we've been making machine interfaces for 15, 20 years. They're all in here. The different ways of connecting, actually this is one of two. Here we have many kinds of connectors. These are all things that we know are proven in the industry. We've already connected to those. What's different is instead of having to download all of these from a server onto a PC with Windows updates and virus protection problems, you just put the box there and plug it in, and it's as simple as that. But it's existing technology, but made in such a way we combine the machine interfaces with OML. People need to do just one interface. For example, from kick machines, you can take and give information through for traceability, but you can take information about the production plan, about kind of issues to do with the boards themselves that may be useful for you to optimize your process.
Yeah.
So it's not just bringing value for the customers, it's also bringing value for machine vendors.
okay. So OML's free, Michael, but we have to buy the box.
Very cost
Anyway,
effective.
okay, thank you for that. Jason, I mean, surely if you're going to start out in this journey, you're going to start with an audit of what you've got at the moment, you know.
That's what our business does
Right.
when we approach a customer, yes.
Yeah.
That's the first step, actually.
Okay,
The
and you
full
told your
process,
microphone a little bit
the
closer.
full process and requirements audit. And what we find, actually, and I agree with what Michael said, it starts, the hardware selection and up. But we actually encounter, and we're engaged in a lot of discussions where the customer has to make a decision. Are they going to put a platform in place that solves an immediate need? Typically, they're grappling with an immediate need. It might be a customer telling them they require traceability, or it might be yield issues, whatever it is. And sometimes customers will approach automation from a perspective of, I have to solve this point emergency now. And that often leads to suboptimal solutions next year, 6 months, when when the emergency changes.
Yeah.
So we're often in discussions where we're talking about platforms versus point solutions, and that's I think that's a good discussion. Some customers only want to address the immediate need. Others look more proactively towards what platform do we need to solve anything going forward.
Right. Okay. Yeah, I mean, Bob, I mean, when customers come to you on factory automation, is it something that's driven by a customer requirement, or is it something that they're looking to, they've thought about implementing because they want to improve the process?
Well, yeah, naturally they want to improve the process. It can come from many things. In the last 10 years, the majority of our customers are EMS companies. So they have to do what satisfies their customer or enables them to get the customer in the door in the first place. And it's a difficult situation because they're running a lot of different products. They can't standardize like an OEM. They don't have control of the design of the product of the customer, which is a big problem. So it's a challenge to try to get them. And if I go back to when we founded SPEMA, we founded SPEMA because machines couldn't fit together, right? The conveyors were front rail fixed or rear rail fixed or center justified, this height, and the other height, this direction, that direction. And we made some basic rules at SPEMA, so as competitors, the customer could pick our machines and fit together. And then we went a little handoff standard so the conveyors could coordinate each other. But over the years, getting a standard for communicating has been almost impossible. And it's been impossible because we're all competitors.
Right.
And because they wanted to communicate their way, and they don't want to give an advantage to the other guy. And, just looking at the placement world, because we're usually the machine that's, looked upon first.
Right.
There are companies in this hall that want to sell you the whole solution, including the software. There are companies in this hall that don't have the whole solution and want to get one. There are companies that are part of the solution and want to find somebody with the rest of it. So, I in principle am not opposed if somebody has a good standard, as long as it's available. As far as the box goes, well, I have to find out if it's a monopolistic box or if it's a pluralistic box.
Oh, definitely pluralistic.
Are you going to become the box source of the world, or is there going to be more? So I need to see more details and whatever. But I do think that, getting a standard would be of value to everybody eventually. Maybe not in the pocketbook initially, but certainly it would be the customer's value. And in the end, our first obligation to business is to make a profit, but our second obligation in business is to serve our customer and see that they're satisfied. And, if this makes it easier to do that, then, there's a lot of good to start right there.
Okay. Bjorn, what sort of questions are you getting from your customers, when they're looking for, automation, factory automation improvement? Are they driving your development at the moment?
Yes, I think the way I'd like to answer your question is you started this discussion with it's a journey, and that's
Right.
very much the case. The Chinese equivalent is made in China 2025, which shows you that they have about a decade perspective on it, although they may start a generation behind the Western world. But this is going to take many years, and it may be very overwhelming for a company that wants to get engaged here is where do you start? And I think the answer to that is where can you get the most benefit? Where can you save the most money? And one thing that has always struck me as kind of peculiar is visiting factories in the United States. It seems like the vast majority of the time I walk through a factory floor, the machines are standing still.
Yeah.
So it doesn't matter if it's the best pick-and-place machine in the world. If it's not running, it's not making you any money. And I think there's a huge opportunity to reduce the downtime. Either, in particular in Europe and United States, where you have a lot of production line changeover, and with the expected smart factory, you're going to produce products with bigger and bigger varieties. So you're going to see more and more production line changeover. And for example, on our side, you may have a $3 million production line sitting, waiting 20 minutes for a $50,000 reflow oven to stabilize on a new recipe. And with this data analytics, you can actually reduce that to zero or to at least a few minutes. So if you look at the ROI calculations on something like that,
Right.
I think that's the first place you want to start.
Well, I mean, you're talking with reference to the oven setups and that sort of thing, which is a bottleneck. But a lot of the pick and place companies as well have obviously got systems for fast changeover, fast kitting, making sure products next to the line. That's why we're seeing all these big towers appearing inside the factories and this type of thing.
Yeah, that's very true. I mean, if you can eliminate downtime and keep the machines running, your ROI goes up tremendously. And I think the storage towers, which I'm happy to say we were one of the pioneers of, and is rapidly becoming a bigger and bigger part of our business, are part of that. Because now when a refeeder is running low, we can signal we need another reel, and the tower can produce it and send it to the line before it is needed. And that means the line doesn't have to sit there waiting while somebody runs to the warehouse looking for the part. And just things like that help the customer be more efficient, get a better return on his investment, and I think we're going to see more and more of that.
Right. Just as an aside, this is I was just thinking there that Terry Gowd's talked about this lights out factory for years. The one thing that is always going to stop that is the feeders. It's almost impossible to automatically feed the feeders. You're going to have an operator there at all times. So do you see that changing?
Well, there are auto-loading feeders on the market. I think it was introduced originally by our friends at then Samsung, now Hanwha. And everybody now, this is the holy grail in the placement deal, is do you have an automatic feeder? Will you have an automatic feeder? What is an automatic feeder? The problem with even automatic feeders is you feed the tape in. If the tape is within a certain thickness and specification, it works. If it's not, it jams, right? Maybe it works for paper tape, not for plastic tape. Maybe you need a different feeder for this tape and that tape. So I think we still have a long way to go on the road to tape utopia.
Right.
In our business. I mean, we're working on it along with everybody else. I can't think of a single placement company in here that doesn't either have one already coming out or will have one coming out shortly. But it's not going to be a nirvana. You're
Right.
still not going to be able to turn out the lights all the time.
Not for a while, yeah. Okay. How important do you think developments are in sensors and vision technology towards improving data collection?
Well, they're absolutely critical. I think what everybody's beginning to realize Industry 4.0 is all about how much data can you get into the central system to analyze it and get benefits from it. But we find it's actually overlooked a lot, is just the mere identification of either incoming materials, all those IDs, or the flow of the products moving through the process, especially in conveyorized situations. Acquisition of the ID is actually a very big problem for many customers.
Right.
People don't, unless you're dealing with laser marking, people don't put labels always in the same location. There's problems with reads. And when you have to keep lines running, a single failed scan in a totally closed loop controlled environment is a major problem. So sensor evolution has actually helped our customers a lot because they're getting so much better.
Right.
And certainly connecting to systems like KIC is another data point that sometimes maybe customers don't even realize the things that KIC is working on is really remarkable in terms of how you can leverage data in ways regarding the information coming from the process that you might not immediately even realize when you join it to the rest of the data from the sensors and the rest of the process.
Right. But do you feel there's still some way to go with sensor technology to really be able to, it's developing all the time?
It's really an exploding area of technology. There's no doubt about it, especially with the autonomous vehicles and everything. Sensors are everything, but I think what we're seeing is the sensors are getting better and the cost is coming down, which is really good for customers that have to deploy an awful lot of them.
Right.
Yeah, I think to expand on that, because you're right, the use of that data can be incredible. If you are collecting information for traceability, for example, I mean, today we're looking at the nth degree of quality where you can make 10,000 products, you get one that fails. Why? What was the unique set of circumstances that caused that to fail? It's not obvious because we'd have found that already. So you need to have that complete build record, and that is as a result of the collection of all of that data from all of the sensors, putting it into an environment where you can apply the appropriate analytics, and then you find it. And guess what? In the same time, you're collecting the data automatically, so it's very low cost. You're able to use it for process improvement. You can use it for counterfeit materials, for example, to be able to track back to find exactly where the responsibility was that counterfeit component came in. So you've got the detection, but you also need to have the feedback, make sure somebody gets prosecuted,
Right.
I mean, this is how to stop it. So it's essential. Information and the gathering of information and the use of it amongst the whole of the shop floor and up into the enterprise is absolutely critical for the future.
Right. And you're doing most of your sensor development through cyber optics.
No, I mean, Cyber is one of our suppliers of sensors. I mean, we use Siemens in Japan a lot, one of the bigger deals. But, I can say sensors are improving, but they still have a way to go. I mean, barcode reading, for instance. If you have laser-etched barcodes into a board and you get a little bit of a moderate one, I mean, that's very finicky on whether it reads or not still, whether you buy it from Cognex or whether you buy it from Microscan or whether you buy it from Symbol or whoever you buy it from. There needs to be a little more, because as you get lines that are more and more automatically monitoring and you collect all this data, you're right. You don't get the data at one point, you got a glitch. If the whole thing stops, it doesn't do you much. So, there's still ways to go on the improving, but I agree that the sensors today are, 10 times better than they were 15 years ago.
So we have a unique problem in that we would like sensors inside these ovens that are running at maybe 330 degrees Celsius.
Right.
And so that it remains a problem for us. We've seen a tremendous improvement in sensor technology, but they stop short at a higher temperatures.
Well, I mean, you could use a whole range of different sensors, like gas sensors and all sorts of different ones to feed into your data collection.
Exactly.
Yeah.
I think that the revolution we're about to embark on now has a lot to do with data analytics and being able to share and process that data. But it all starts with acquiring the data in the first place. is. And if the sensors aren't capable of doing that, you can't go to the next step.
Right.
And that remains a challenge in our end of the business, in the thermal process.
Okay, good to know. Okay, so, robotic companies such as ABB, KUKA, Bosch, Rexroth are starting to appear more at SMT shows. We saw a lot of them at Productronica. Will machine vendors and software companies start working closer with these companies to develop more intelligent loading and material handling systems? Who wants to pick that one up?
Yeah, I actually think it's an interesting field that's developing because after the surface mount line, there's a great deal that happens, especially in upper level assembly, that involves these robots. And these robots are typically driven by PLCs, so it's a different integration challenge in terms of data and control. But you're right, you raise an issue is how, the surface mount has evolved a great deal in automation. I think sometimes we maybe forget that because we're so immersed in the industry. But when you get into the post-processing, there's a lot of manual cart moving, very manual processes to get the raw materials to the point of use. And that is a frontier because it can only really be controlled by upper level systems.
Yeah.
Yeah, I think the use of the robots, like the ABB example, they have arms now that are moving around and can touch and feel things. And it means that they're not really dependent on programs anymore.
Right.
I mean, if you look at how to set up a line of traditional automation, there's an awful lot of teaching, changeover to do setup of things. Materials have to be positioned just so. Whereas the robots of today, they come along and they kind of know where they are and they just pick them up. And so this is quite a revolution because if we're starting to have our factories be a lot more flexible, as you mentioned, they're going to make a wide variety of products, maybe 2 or 3 or 4 off. You need to be able to change these processes over. So they have to be more intelligent in what they're doing. And the addition of the sensors enables them to do that. So how we see this integrating with, let's say, the mainstream machines, which we can never do without because of the sheer volume of chips that we need to add, I think there's a great road that we need to go down to enable machines to be less like machines and more like things that can sense and feel things. And that will be a great advantage for flexibility in the industry.
I was recently visiting Blue Sky, Jabil's Blue Sky in Silicon Valley, and they have a whole room there with robots. And it was very interesting because I always expected robots to be something to replace labor. But they're talking about new robots that are have sensors, and they're designed to work shoulder to shoulder with human beings. So they make them very safe so that if a human being gets in their way, they stop immediately and so forth. So. And the same thing out of Robert Bosch in Europe. You see a future they're planning that isn't necessarily replacing all human labor, but having a new sort of symmetry between human labor and robots. So the type of robots now being developed is completely different from just a few years back.
Absolutely, yeah. They can sense the human working on the line and just literally go around them, and we've seen it quite often. Yeah.
Well, as probably the oldest guy here on the panel, I can say that I've seen a lot of change in the robotic industry over the years. I remember the first show I was at in Chicago, where we had a robot show combined with kind of a electronics assembly show in Chicago. And across the aisle from me was this huge hydraulic actuated robot that stood about 10 feet tall, was actually anchored into the ground on a huge metal plate. Right? And they wanted to show that this giant, powerful robot could be gentle. So they had a refrigerator and a can of beer. And the robot would open the refrigerator door, reach in, pick up the can of beer, put it out, put it on a table, pick it back up and put it back in the refrigerator and close the door.
Right.
And not dent the can of beer, which in those days was probably a steel can, but could have been an aluminum can. So this worked great for about 2 days, first 2 days of the show. And the third day I had my back turned, I was talking to a customer in our booth, and I hear this shriek. And I turn around, and this robot, apparently the sensor that told it the door was closed failed. And the robot put its arm through the door, grabbed the can of beer, picked up the beer with the refrigerator, and slammed it down on the table, right in front of this woman who fortunately wasn't hit by it, but and she was shrieking, and that was the deal. So my respect for the power of robots went up tremendously after that. So, today, yes, we see it a lot. I mean, Terry Gao at Foxconn has said by the end of this decade he will have 10 million robots working in his company. I think anytime they make a statement in a country like China, where the manual labor, I remember people that asked me if they could get rid of the conveyor because they could reverse and hand the board from one machine to the next, I think is tremendous progress. So I agree with you. I think we're going to see a tremendous amount of growth in this area.
Right. Yeah, I think it's going to be an interesting area, and that's going to be a new area that we're all going to have to start working with a lot more going forward. Okay. Big data is pretty useless unless it's accurate data. It has to be accurate and actionable. Does the panel think this will influence the future design and build of production equipment to make them more, you see laser systems, for example, they've got granite bases they have to have so that they have the accuracy to do the cutting. But are we going to need that sort of level of stability in our production equipment to be able to get accurate data? Because if it's even a micron or two off, or a few microns off, it's going to have
Well, I mean, you're going to look at another generation of equipment because, in my career I've had the experience to be in the semiconductor side of things when we made a machine called the Micron 2 for Intel when they converted to flip chip inside the Pentium package and changed over from wire bond. That machine had an accuracy of plus minus 10 microns true position to place the flip chip in the Intel package. Today's placement machines that you find in the hall are probably somewhere between 25 and 50 microns plus minus true center position, and that 50 microns is all you need for the placement of a small chip.
Right.
Some fine pitch, some small mini ball devices, maybe the 25 microns is enough. So I think you're going to see, if you need that much more accuracy, you're going to have to see another generation of machines developed, and the question with accuracy is always speed versus the mass you're moving. The base has to be much more robust if you want to move really fast but stop really accurate. And so that's going to be expensive. And the trend of placement machines is we have to deliver more CPH every year for less money and include more features on the machine besides. And it's a very difficult business to engineer in, very difficult. We've seen a couple companies go out of the industry in the last couple of years, and I think we'll see a couple more go out. So, wait and see, but they'll be pulled kicking and screaming because of the cost.
Because of the cost. Right. Can you share that?
Well, I'm not an expert on machine design itself, but I do think that there's an issue of data depth when it comes to big data.
Right.
We're always grappling with machines that are data generators. All machines are data generators. And the depth of the data that the customer knows the machine has, but the machine currently is not exposing it, is an ongoing problem in certain cases. And it's getting to the point now where most machines generate a good wealth of data, but the customers are asking for more and more. The detail, especially in the inspection and test machines, just the depth of the data that the upper level systems are now requiring, because they want to do all sorts of interesting analytics that before barely anyone was even thinking about.
Right.
So that's what we see, is more depth than accuracy.
Yeah, I'm seeing that too. I mean, for example, one factory that I keep referring to, the Siemens factory in Hamburg, they coalesced around the Simatic backbone from Siemens, but the key thing is that they reduced the number of suppliers they had, first of all, and then they insisted that these suppliers all adopt their software system and have a complete open access to the supply of materials into the factory. They also supply the same, by the same token, to customers at the other end. Customers can also look into the factory and see exactly where their product is and the progress of it. So, do you think we're going to start seeing this becoming the norm going forward?
Just to mention about the depth of the data, I completely agree with that point. I think, though, that the accuracy is something that should be taken for granted. It's got to be absolutely fine. I mean, we all know, garbage in, garbage out.
Right.
But today, if you go into a plant, they're gathering data, perhaps manually, perhaps taking data from the machines, and they all sit down in a meeting. There's guys, they're engineers, managers, and they're trained to look at the data, really see through the data, try and interpret what it is, go and chat to a few people, a few phone calls, to get to the root of the problem. Now with Industry 4.0, we want to take those people away We want the decisions to be made for planning or for lean materials, as you were saying, to pick the materials without human intervention.
So you also want to see the defects before they happen and do something about it earlier in the process.
Exactly.
You don't want a meeting a week later to say, well, this is how much we messed up.
This is what we lost.
This is what we lost
Well,
last
I
week.
hate to tell you, a lot of factories are already gone.
Yeah.
So it'll be nice if you can do it automatically. I mean, I've been shocked in the last couple of years with the lack of process engineering ability at huge corporations,
Yes.
where we come in to install the machine, and we have to also install the process. I mean, my people are, I have to send an applications engineer to do the process and train the people because there is no process engineer to support the process because they're lean.
It's like you're providing consultation.
Well, you know, lean, and I would say they're practically starving, but you know, this is where we're headed, and so if you guys with the data can help correct issues and keep the process on track, it's not just going to be valuable, it's going to be absolutely necessary because these guys have gotten lean down to the point where there is nobody there to do it.
No, they're just pushing it back on the supplier. You know, in the same way that the OEMs are pushing the R&D back on the contract manufacturer.
Yeah, but
I don't think
it's
it's
our
bad.
place to make sure a machine works properly and the people are trained how to use it. I don't think it's my place to go in and engineer their customers'
Exactly.
product process.
Right. No, it's true.
And I don't want to be responsible for that neither because I didn't sign up to that. So, I mean, it's getting in some places to that point.
Regarding the question on the sensors, you could also make the opposite argument that sensors and the data and the analytics you get from that can make up for some imperfection in the machine by doing corrective action or alarming and so forth. So it's helpful for machines today that you retrofit these types of capabilities that isn't perfect, and it helps the machine do a better job than otherwise.
Okay, so the poorer the machine, the more sensors it needs.
Good for the sensor guy.
Okay, well, gentlemen, I think we've pretty much got to the end of this debate today. I want to thank you all for taking part. It's been an interesting debate. We've covered quite a bit of ground on it. As I said, it's an evolving area, it's a developing area, and we're going to have many meetings, I'm sure, in the future to discuss it. So I want to thank my panelists from the right, Bjorn Dahl, President of KIK, Bob Black, President of Juki Corporation. Thank you, Bob. Jason Spira, President of Aegis Corporation, and Michael Ford, Business Development Manager for Mentor Graphics. Mentor Graphics Valor Division, I should say. Okay.
We answer to anything.
All right. Okay. And I want to thank our audience for watching. Thank you very much, and